This is a video for the final review in my Calculus 1 class. The directions say to evaluate the limit. So let's take a look at problem 1a. So in 1a, we have the limit as x approaches 3 of x squared minus 9 divided by x squared plus 2x minus 3. So this can be written as the limit as x approaches 3 of. Now, the numerator is a difference of squares, so I can write this as x plus 3 times x minus 3. And if I were to factor the bottom, it would be x plus 3 times x minus 1. Now, the x plus 3's cancel, and what we get is the limit as x approaches 3 of. In the numerator, I get x minus 3. In the denominator, I get x minus 1. And so when I replace x with 3, I get 3 minus 3 divided by 3 minus 1. And that's equal to 0. And that's how we do problem 1a. Let's take a look at problem 1b. Suppose I have the limit as x goes to negative 3 of x squared minus 9 divided by x squared plus 2x minus 3. And so, again, this is equal to the limit as x approaches negative 3 of. In the numerator, we have x plus 3 times x minus 3. In the denominator, we have x plus 3 times x minus 1. Now remember, x is approaching negative 3. X does not equal negative 3, and so that's going to allow us to cancel those factors. And what we get is the limit as x approaches negative 3 of. In the numerator, we get x minus 3. In the denominator, we get x minus 1. So by direct substitution, we get negative 3 minus 3 divided by negative 3 minus 1. And so that's negative 6 divided by negative 4. And the correct answer for 1b is 3/2. Let's take a look at 1c. Suppose I had the limit as h approaches 0 of. Now, in the numerator, we get h minus 1 cubed plus 1. In the denominator, we get h. And the way you can attack this is as follows. So if I cube out h minus 1, I claim you're going to get h to the third minus 3h squared plus 3h minus 1 plus 1. That's the top. On the bottom, we get h. Now, this is the limit as h approaches 0 of. Now we get h cubed minus 3h squared plus 3h divided by h. And what you can do from here is one of two things. We can split the fraction, right? And so, in other words, we can write this as the limit as h goes to 0 of. Now we get h cubed divided by h minus 3h squared over h plus 3h over h. So that's one way to attack it. You can split the fraction, right? I'm just going to write that third term a little cleaner. Or In the numerator, I can factor out an h, and that's totally fine. And so here, this is the limit as h goes to 0 of h squared minus 3h plus 3. And so if I do a direct substitution, I get 0 squared minus 3 times 0 plus 3, and the correct answer is 3. That's 1C. Let's take a look at 1D. Suppose I had the limit as x approaches 2 of, I get x squared minus 4 divided by x cubed minus 8. I want practice in factoring, canceling, things of that nature. So this is the limit as x approaches 2 of. If I factor the numerator, I get x plus 2 times x minus 2. If I factor the denominator, I get x minus 2 times. I'm going to square the first term to get x squared. I'm going to multiply these two terms together and change the sign, plus 2x. And then I'm going to square the last term to get plus 4. Okay? So that's how you factor the difference of cubes. Now, as long as x is not 2, I claim I can cancel these factors. And x is not 2. Remember, x is approaching 2. There's a difference. And so this is the limit as x approaches 2 of. In the top, we get x plus 2. In the bottom, we get x squared plus 2x plus 4. And we're in the home stretch. Because from here, I can replace x with 2 and get 2 plus 2 divided by 2 squared plus 2 times 2 plus 4, which is 4/12, which is equal to 1/3. And that's how we do 1D. Let's take a look at 1E. Now, 1E is very interesting because we got the limit as x approaches 3 from the right of. Now, in the numerator, we get 3 minus x in absolute value. In the denominator, we get x minus 3. But we have to talk about something. Now, I want to write down the meaning of the absolute value of 3 minus x. Now, the absolute value of 3 minus x is defined as follows. I can strip away the absolute value, right? In other words, I can just write 3 minus x as long as 3 minus x is greater than or equal to 0. But you have to write the opposite of 3 minus x. If 3 minus x is less than 0. Now, you might ask, well, why? Well, when you take the absolute value of, let's say, -5, you have to get a non-negative number back when you take its absolute value, right? In reality, what you're doing is taking the opposite of -5, okay? And the opposite of -5 happens to be 5. Because remember what the absolute value is doing. It's measuring the distance from 0 to -5 on the number line. It's measuring this distance between these two values. That distance is 5. But to get at that number, I got to take the opposite of that -5. And if I take the absolute value of 5, I just happen to get 5. Okay? And so when I have 3 minus x in absolute value, I can take away the absolute value and just write 3 minus x as long as 3 minus x is greater than or equal to 0. Now, another way to say that is that x must be less than or equal to 3. And then the absolute value of 3 minus x is the opposite of 3 minus x if 3 minus x is less than 0. But another way to say that is that x is bigger than 3. Now, look at where x is approaching 3. X is approaching 3 from the right. Okay, so here's 3, and x is coming at 3 from this way, which means the values of x are going to be larger than 3. I hope that makes sense. And so what you're going to get is the limit as x approaches 3 from the right of. So I'm going to get the opposite of 3 minus x divided by x minus 3. Now, this is equal to the limit as x approaches 3 from the right of. In the numerator, we get x minus 3. In the denominator, we get x minus 3. Now, let's go to the next page. And we can say the limit as x approaches 3 from the right of x minus 3 divided by x minus 3 is the limit as x approaches 3 from the right of 1, which is equal to 1. Therefore, the limit as x approaches 3 from the right of the absolute value of 3 minus x divided by x minus 3, well, that must equal 1. And that's how you do 1e. Let's take a look at 1f. Suppose I have the limit as x approaches infinity of the square root of x squared minus 9 divided by 2x minus 6. And if I want to test your ability to evaluate limits, I'm going to do a problem like this because you won't be able to use L'Hopital's on a problem like this. So it's beneficial. So I'm going to take the limit as x goes to infinity of. Now remember the trick here. In the denominator, I can take an x out, right? I can factor out an x. Now when I do that, I get 2 minus 6 divided by x. In the numerator, within the radical, okay, I'm going to factor out an x squared. Now, when I do, I get 1 minus 9 divided by x squared. But remember, the square root of x squared is equal to x for x positive. And remember, x is going toward infinity. So how am I going to rewrite this? It's the limit as x goes to infinity of. We get x times the square root of 1 minus 9 over x squared divided by x times 2 minus 6 over x. Now, notice how the x's cancel. They're gone. And so I'm going to write this as the limit as x goes to infinity of. In the numerator, I get 1 minus, if you don't mind, I'm going to write 9 times 1 over x squared. In the denominator, I'm going to write 2 minus 6 times 1 over x. As x goes to infinity, 1 over x squared goes to 0. And so does 1 over x. And so the correct answer here will be 1/2, because the square root of 1 is 1, and then I'm dividing by 2. And that's how we do 1/f. Now, from there, what if I ask you to find the derivative? So we're going to start that process. And this is going to be number 3a. So suppose I give you f of x is equal to tangent x divided by 1 plus cosine x. And I'm going to hold you to being able to simplify, where appropriate. So f prime of x, if I apply the quotient rule, I'm going to take the bottom and I'm going to multiply by the derivative of the top, which is secant squared x. Now I'm going to go minus tangent x times the derivative of the bottom, which is negative sine x. And I'm going to divide by 1 plus cosine x raised to the second. Okay. Now, this is equal to, I'm going to get 1 plus cosine x times 1 over cosine squared x. A negative times a negative is a positive, so I'm going to go plus sine x over cosine x times sine of x. And I'm going to divide by 1 plus cosine x raised to the second. Okay, now, if we don't mind, I'm going to distribute the 1 over cosine squared x inside. And when I do, I get the following. F prime of x is equal to. Now, I'm going to get 1 over cosine squared x plus 1 over cosine x plus, right? And then I get sine squared x divided by cosine x. That's the top. The bottom is 1 plus cosine x raised to the second. Just one final step. I'm going to multiply the numerator and denominator by cosine squared x divided by cosine squared x. Why do I do that? The reason why I do that is because I want to clear that fraction. And so my last step, I'm going to write 1 plus, right, because I'm taking this term in the numerator times cosine squared x. And then 1 over cosine x times cosine squared x. And that'll be 1 plus cosine x plus cosine x sine squared x. That's the top. The bottom is 1 plus cosine x raised to the second. It's important to be able to do that. Okay? And that's 3a. 3b. Suppose I give you x e to the y equals y sine x. So this is practice in implicit differentiation. So I'm going to differentiate both sides with respect to x. So the derivative of x e to the y with respect to x is the same as the derivative of y sine x with respect to x. Okay. From here, I apply the product rule. So I'm going to get the derivative of x, which is 1. So I get e to the y, the derivative of x times e to the y, plus x e to the y times dy dx. So in other words, it's the derivative of the first times the second plus the first times the derivative of the second. And I basically do the same thing over here. So I get dy dx, that's the derivative of the first, sine x, plus y times cosine x. Now, from here, I get x e to the y dy dx minus dy dx sine of x. That's the left side. On the right side, we get y cosine x minus e to the y. So, does that make sense? I took this term here, I moved it over to the left side of the equation. Then I took this term and moved it to the right side of the equation. Now, factoring out a dy dx, I get x e to the y minus sine of x. And then this is y cosine x minus e to the y. And then if I solve for dy dx, I'm done. So in other words, I get dy dx is, and I get y cosine x minus e to the y divided by, and then it's x e to the y minus sine of x, right? Perfect. And that's how we do problem 3b. And that might be a good stopping point for this video. And this is a video from the final review in my Calculus 1 class. So we were able to do problems 1A, 1B, 1C, 1D, 1E, and 1F. And then we looked at problems 3A and 3B. Okay, thank you.